To you all. Yeah, that works too. So, this year there's 84 of us from the usual places. To you all. No new exotic places in the world where we gather people from. But this year there's 84 of us. 84 of us. From the usual places, no new exotic places in the world. This year there's 84 of us from the usual places. Remember last year, no new exotic places in the world. But this year there's delegates by country. It insisted on doing it the exact opposite order. So last night I spent 2 hours cutting and pasting and manually editing these two so that they would match. I promise you next year I'll spend only 15 minutes and I'll use APL and I'll use Sharplot to do this. So. There's a little bit of logistics here. When you get here in the morning, you have to use door 1. That's this door here. And that's a natural one to use when you arrive. And you got here, all of you, didn't you? When we have coffee breaks, you have to use door 4. That's the one up there in the corner. And that'll take you out to a little balcony where there's some tables and stuff, and then you have to go up one more stair, and there's the coffee and water and tea and biscuits in the morning. And obviously, when we leave for lunch or dinner or whatever, that's the door you have to use again. There is a corridor between this place and the Hilton Hotel. I don't know if you all found it, but if you go to the end of the bar, there's a passage there, and you have to go down some stairs, and you'll end up almost outside of this room. You have to turn right but there's actually no turning left, so it's pretty obvious. That corridor won't be open all the time. It'll be open about half an hour before we start in the morning. It'll be open all during lunch, and it'll be open until 30 minutes after these sessions have ended. So it's apparently going to be even colder, so you might want to scoot through that one as a convenience. The banquet is tonight. It's taking place in the Lagan Suite in the Hilton Hotel. We will start with drinks at about 7:30 and have dinner at 8. That should allow also you who live remote to get back and scrub up a bit before the party tonight. And the dinner will be followed by music, dance, with a Kilik band. So remember not to wear clogs. Use your dance shoes tonight. So, you will have noticed that we haven't tucked you away in a nice little remote conference center where there's really nowhere to go, and we are sure that you're sleeping there, you are eating there. This year we are in the middle of a larger city, Belfast, and there's a lot of nice facilities around, so we have not tied you down to a particular place to sleep and a particular place to have dinner. And this is because some of the younger people use the feedback forms to tell us that they'd like to go different places each year, and they'd like to be able to get out of the conference center at night and see the city that they're visiting. I'm the organizer. I would love to go to a law school every year. I know that works. I know how it works, and they know us, and so it's usually a very enjoyable But I also do remember when I was a young person, I loved going places every year for the APL conference, seeing a different place, meeting different people. So I think we have to offer that as a community. So yeah, and the other thing I wanted to say, having the banquet tonight is actually also a request. Do the social stuff first. And I thought this year, because we are in a big city, yes, we should probably have the party to start with, so that you can gang up with people you like and want to get to know and arrange for the rest of the week. The half-day excursion, which is usually on Wednesday, is tomorrow. We are going to see the Titanic Museum and enjoy that event. So we pretty much killed all our darlings, everything we knew how to do, and everything you came to expect from coming here from year to year is all different this year. So get used to it. But do remember to tell us if you like the changes, or if you don't like them, because we do listen. And if you don't tell us what you like, somebody else will get what they like. So remember that. Okay. Why is it so slow to show me what I'm... Okay. So, as usual, we have a couple of new faces at Dyalog. Firstly, Will Robinson. Where is he? Right. Get up, man. So Will is, he spent some time taking lessons from Adam on Stack Exchange. Adam has been running a series of lessons in APL, and Will got interested and expressed interest in doing an internship at Dyalog. And one day last year, he arrived with his parents. Well, his parents were not supposed to be there, but traffic and stuff made it so that they were sitting in the living room while we talked to Will. But we agreed mutually that it was a good idea for him to do an internship at Dyalog, and I think we were approved by your parents too. But, I mean, obviously Will has to take his university education, so he's left us again, but he's still doing the odd job for us, and will continue to do so, hopefully, while he's studying. Right. So that was Will. And I think there's a trend here, because one day, not too long ago, a man and a dog and a younger man arrived at the offices at Bramley, inquiring about what we were doing and what was this software business. And a few weeks later, we got to talk to Richard alone. Richard, where are you? Come on, down here. And he turned out to be a really sensible person, so we mutually agreed, and he lives in Bramley, by the way, that he would be a good match for the data scientist position that we have had open for a long time. And he's already starting to pull his weight, so I think you'll see more of him. Right. Yeah. Good, yes. And then there are the winners. Alve, where are you? All right. Alve is the winner of the student competition, the worldwide problem-solving competition. He will tell us about his experience on Wednesday afternoon, as usual, and get his prize certificate handed over. But also on request, present the winners early so that all of the other people get a chance to talk to them during the conference. So here he is, and take your chances. And then this year, we actually have the winner of the professional competition with us as well. That's Tiziano Berchi from SimCorp Italiana. In previous years, it's been a Canadian who has won, Mike Powell, and he also did an excellent job this year. But this man superseded him and won the prize. Tiziano is a little bit shy about his English, but he apparently understood what I was saying, so just be kind when you try to attack him with very fast English. He won't get you. So, that was the changes we made. Now there's the changes we plan. Cross-platform has been on our agenda for the longest time. I think we actually started that when we got into Dyalog in 2005, and they had already been doing it for a long time. The thing is that you can actually exchange data between different platforms and also different versions. Not all of them, not the oldest one. We have to sometimes take an intermediary step by saving it in an older version and then loading it from there. But platforms are both versions. It's hardware platforms, and it's user interface platforms, etc. But it's important these days. You need to be able to develop in one place and deploy in another place, and you need to be able to do it fast. These are the platforms that we support. It's Windows, it's AIX, Linux, macOS, and the ARM processor, which is used on the Pi, the smaller school computers. And you will see that Windows and AIX, that's where the majority of our users are. We support all the different environments. For Linux, we only provide Unicode 64-bit. Same for macOS. And the ARM, I mean, these are small computers, so they are 32-bit, but it's still only Unicode. They are all built from the same source, the same set of code. And they are all built and tested every night. And it does take almost all night to build all of them. Okay, so, yeah. So I should stand with it back to you and see what I'm doing. The classic doesn't really belong there. I mean, in the new environment on the internet with the browser technology. I mean, all that stuff is Unicode. And classic isn't. And classic does require us to take a lot of considerations while we are doing development. It slows us down in taking advantage of some of the new architectures and stuff. So, yeah. Currently, we are planning 2 more releases, 17.1 and possibly 2. But we are also planning a major new release where we put in new data types, where we release the restriction on number of dimensions. So, I mean, with the new one, you should be able to model the creation of the universe. I think I've heard it takes 19 dimensions, and you can't currently do that. We also have people who are doing planning sales breakdown. I don't know that that's a good idea, but they can do it with this new release. But those changes require us to go through pretty much all of the interpreter in order to make sure that these new data types work everywhere. So we have for a long time warned you that new functionality might not be possible in the classic version, but only in the Unicode versions. And we've also made new features that only work there, only to have to backport it, because some of the customers using Classic still want that new functionality, and so they got it. But it's becoming more and more obvious that the new browser-based application is the way that the future computing is going, and where applications are going to be deployed. And they all use Unicode. Also, modern text-based source code management is Unicode dependent. Well, we can work around it, but it's a lot of work. So we are contemplating not releasing a classic version 18. It will allow us to refactor the interpreter and tidy up all these old technology things that are still in there and takes time, and it would improve the performance, and it will make the interpreter simpler to work with. Obviously, we know that some of you are using Classic, and we'll definitely talk to you about this, but there might be some of you who we don't know are using Classic and who are in doubt of what to do. So please, if you're in that situation, come and talk to us, and we're more than willing to help you move to a Unicode environment. It's usually very easy, but there can be situations where you need to be careful. Alexei Miroshnikov did a talk a couple of years ago on what to look for, and we will also be able to help you. For those of you who we know are, we'll talk to you too. But don't worry, because version 18 will not be next year. It's like at least 2 years out in the future, and after that there'll be another 5 years where we still support the classic versions. And if the worst comes to the worst, we can still make you a separate branch, and we don't ever leave anyone in trouble. Yeah, there's one more thing I want to talk to you about, licensing. And now you're all scared, but it's not that bad. Actually, we are now very, very close to be able to provide a cloud-native APL. And we're so close that we have to consider how we are going to charge people when they use it. The problem is that for people to start using it, it has to just be there as a package in a container that you can just describe in one line in a text, in a script file, saying, I want this to be available in my Docker container, meaning APL. And so that it can be used for automated deployment of applications. If you have a little APL applications, you want to deploy it on a massive amount of computers on Google or Amazon or Microsoft's cloud service, you want it to be easy, and you want it to just scale to thousands of instances. And if you want that to happen, you can't have it stop and ask you for license and password for each individual user. It just has to be easy. Morten will give you an idea about how this environment is going to look just when I'm done. He will talk some more about it on Wednesday, and he will even give a workshop on Thursday afternoon on these things. We think it's really, really important. If you want to be on the front ends of software development, you need to be able to use these things. And we think that's where our new users is also going to be. So this is important. Pay attention. The packages will be for Linux. That's how you do these deployments. On all these cloud platforms, it's mainly Linux. The end-user application can run on a Windows PC or Mac, but the server side of it is usually Linux. And that's where we'll make these packages available. It won't be free software. You still have to pay for it for commercial use. But it'll be very easy to get hold of, and it'll be very easy to deploy applications. So, before I stop here, I just want to say that something doesn't change. Today, we have brought pretty much everybody from Dyalog, except Vince, who's back there manning the support desk. So could you please all get up? And know they are here for your sake. So make good use of your time with everybody at Dyalog. If there's something you like, tell them. If there's something you don't like, get hold of the responsible person and talk to them about it. We're here for you, and we love getting your feedback. So, very welcome to Dyalog 18. We hope that you enjoy all the changes, and we trust that you tell us if you don't like them. So, welcome. You want that one?
No.
Jason? Okay.
Welcome to the second step in the morning presentations. I hadn't really looked at the title slide when I made a thought of this title, and as I typed it in, I thought it does look a little bit strange together with the ship, but there you go. Gita talked about the things we've been doing with cross-platform and so on, and traditionally, the last several years, I've done a presentation that has these 3 bullet points: portability, performance, and functional programming. But I'm going to try and do something completely different this time. I'm supposed to be the Chief Experience Officer. I'm just going to give you a glimpse of what I think the future user experience might look for, particularly for new users and people trying to get on it now. There is, however, the obligatory roadmap sign. This is one I've used before. So as we go to cloud computing, of course, we're going to need different kind of maps. So there's a few new things you need to learn, but don't worry, the things that you know are still there. Everything you know, so Edit School, for example, is up there on the new maps as well. Anyway, enough of that. So I'm going to mainly do a demo for the next 25 minutes. I'm a little bit worried because the last rehearsal I did, everything just worked. So we could be in trouble now. But I'm going to imagine spending a bit of time with a young data scientist. I'm going to call her Mary. It's not Suki here, who was an intern, our intern in 2015. He spent some time with Rogers. He's now gone off to study mathematics. But maybe when she comes back, she might be the person I'm having this imaginary conversation with. And she's been given a bunch of data to analyze. And she says, my professor says you know something about this cool new language for analytics called APL. And I have this idea that before I start looking at these CSV files, I'd like to do something to figure out whether they are fake or real. And the first idea that popped into my head was I'd count the frequency of digits used in numeric fields to see if they have some sort of weird distribution, because that might indicate that somebody's typed them in. So for example, if somebody gave me this CSV file here, I thought it might be a good idea to maybe ignore the first digit in each number, then just look at the distribution there and count them up, and then if I had data like this, obviously there's 8 sevens in there, so somebody was, this data isn't right. And you know what? I can't find a Python library to do this. Can you help? And of course, rather than getting into a conversation with her about why there might not be a Python library to do this, I told her she came to the right place. And she should fasten her seatbelts, we'll go for a ride. Of course, she didn't recognize that symbol on the left. This is what fasten seatbelt sign look like these days. So let's switch to APL. And is the mouse working? Yeah. So I did notice a problem that the demo system seemed to have stopped working, just a minor, yeah. It's not working. I'm going to have to click. Right, so there's her file. She brought it along on a USB stick and gave it to me. Yeah, I'm going to have to do this by clicking. I don't know if anybody else, Dyalog folks, Alt-N in bracket demo just stopped working this morning, and it's very mysterious. I hope it doesn't slow me down too much. So one of the recent additions to Dyalog APL is this quad CSV thing, so I can read that straight in to a variable from the CSV file, call it fields. I can figure out which are the numeric fields by applying this validation, taking the first item of quad VFI, shows me where the numeric fields are. If I turn that into a vector, I can then apply that to the fields themselves. Oops. Yeah, this clicking is going to be fun. So sorry? F12, you think that might work better? It's worth a try. Yeah. I can do the one drop each of the numbers, and I can extract the characters. So here are all the characters we want to do a frequency analysis of, and then I can use the new key operator to get a unique count. Now, they're not appearing in the correct order. They're appearing in the order that they appear in the data, but I have a little trick to do that. If I append all the digits to the front and do key, then I get the results in the order that they appear, which is now 0 to 9, except, of course, the result is 1 too high, but I can easily subtract 1. And there's the result that she was looking for. So then we can do some kind of variance analysis on that and decide that it's fake. So that's interesting, she says, but what if the data's out somewhere on the internet? Well, then you have to load this little library tool that we have, HTTP command. And she says, I thought this crime data from Sacramento is one of the first things I need to look at. Can you get hold of that? Yes, I can do an HTTP command get. And here's the first bit of data for that. Okay, so this is looking interesting, she says, but I use Linux. I don't have a Windows computer. So can you help me get it onto my Linux computer and run it there? And so, okay, let me just tidy it up a little bit. So, as in any good kitchen, I've pre-prepared some things. So, in the folder, there's a function called foo. And I'm going to trace that. Give me a chance to show off the tracer as well. So, here's a variable. We do the HTTP command get. That returns about a megabyte of data. And then we go through the various bits, and at any time we can hover over here and see what's in our variable. And eventually do that last bit of code, and now we've collected it into a function. And here's the code that you want. All right. Why don't we create a GitHub repository so that we can share this data and work together? So we go off to GitHub. And we need to create a repository. We're going to call it D18 Mary. We need to click on the new button first, D18. It's a bit difficult using a mouse on such a steep slope. Yep. Slipped up there. Anyway, so we created the repository. And, 'cause I don't have a there it is. And now that we have the repository, we go to our DOS command line, or Windows command shell, we should call it, and we do a git pull. And yeah, I did screw up, sorry. So just a sec while I try and recover this. I forgot to create a README for the repository, and therefore I believe I cannot clone it. I'm going to delete the repository. It did go too well the first time. All right, let's do it again. Once more with feeling. I'm going to create a GitHub repository. I click New. It's important to do this when you create the repository, to add that README file. I'm not sure why you can't clone it if there isn't a README, but it's important when you do it, you go down here and click Create Repository. And then there's a README so that people can see what it is, and then they should be able to.
You're building Demo, not Mary.
Oh, hang on. Yeah, this is all wrong. This is what happens when you try and set it all up while you're sitting in the stands. To be better prepared and have the demo go more smoothly when you get to the stage. I wanted to do a git clone. Right. And now back to my APL session. And now that I have that repository, which is just in a folder called, it's just a folder that's been created where the content's just containing the README, I can now continue and save that function that I wrote. All right, so I'm going to save my function foo into d18 Mary noodle /foo and create the noodle directory because it isn't there already. And then I'm going to create a folder in there called demos. I'm going to create some data. In fact, there are two files that we might be looking at. And I'm going to use the quad input function to take those two lines of text and put them into a demo file, into a data file called csvfiles.txt, which we'll be using on when we get to Linux in a moment. So if we now open this folder and have a look at it, we have created a folder with foo.dialog. If I double click on that, it brings up a text editor. I can choose any text editor I like. If I go to the demos folder, I have the CSV files with those two lines of text in that I put. Yep. And now, bring up my crib sheet here. I need to now push this data back to the internet, so I'm going to say git add my changes, git commit with the message first noodle, and then I'm going to say git push, and that will push my changes up to the internet. Right. So now we're ready to go over to Mary's Linux machine, and I have to ask her, well, do you have, there are two really important components we're going to need. She's going to need Git that I had installed, that I used to push the stuff up to a repository on the internet so that she can pull it down onto her Linux machine. And And she can, if she doesn't have it, I think these days very few Linux machines won't have it. She types, it varies a little bit from one Linux machine to another, but typically one line. And then the really important component, the one that this talk is really about, is something called Docker. And there's a couple of lines, there's one or two more lines than this, but these are the important ones. So install Docker, add the Mary user to the Docker Linux user group. You need to log out and log back in again, and then Docker is installed and running. Install Dyalog APL. You can do this on the Raspberry Pi. You can't currently do it on Linux. We're hoping once we have the licensing sorted out that you're going to be able to do that. But it doesn't really matter because this magical Docker thing is going to make all of this work without installing Dyalog APL on her computer. So there's a little repository with some script files that she needs that she can get just by doing a git clone of Docker utils. And then she needs to clone the repository that we just built. And instead of this D18 Mary that just contains 2 files that I created, I've actually created a whole bunch of stuff that I'm going to demo. So there's a more comprehensive repository. So she's done all these things. And now we're ready to go over to her machine. So she can start playing herself. So she logs into her virtual machine. And she's done the git clone, so if she does an ls, she can see that she has D18 demo. And it's got Noodle and demos, and it's got a few other things that we're going to look at in a minute. Now, she doesn't have Dyalog APL installed, but she has the script Dyalog C for container, and that's a script file that takes as its argument the folder that she wants to work on. And this very short command line is now going to do a number of pretty amazing things. First of all, if the Dyalog Docker container containing version 17.1 alpha isn't present on her machine, it's just going to go and get it. That would take about a minute, so I'm not going to, I've already got it. This is going to start instantaneously. It's then going to launch the Docker container, which is like starting a completely new computer, really, as a virtual, in a virtual corner of her machine. It's going to start Dyalog APL. It's going to map that folder. It's going to mount the folder D18 demo where she is now into a folder which is inside that machine. So she's going to have something called /app once she gets there, which contains whatever she passed in as the argument there. And it's not copying the data, it's mounting that folder, so it can be shared between the host computer and her stuff. And it's going to start APL with a flag which says we'd like APL to act as a web server and present RIDE as a web site. It's then going to launch Firefox and connect to it. So when she hits enter, it's going to do all those things. And it's going to wait 3 seconds to be sure it's all up. It's going to launch Firefox and direct it to the default RIDE port, which is 4502. So she doesn't have Dyalog APL, and she doesn't have RIDE either installed on this machine. Right? If the Docker container wasn't there, it would have been downloaded, and that takes about a minute the first time you do it. And after that, she just has this environment where she can go in and play with Dyalog APL without having installed anything. And that's why we need new licensing, which allows, where we feel comfortable doing this. At the moment, all the containers that are out there are based on 17.1, which is like pre-alpha. It's completely unsupported. If you play with these containers, don't complain to us if they don't work. Well, actually, please do report bugs. We're very interested. Right, so what she can do now is she can type link into the root app noodle. And what that does is establish a mapping between the root of her workspace and whatever source files are in Noodle. So as a result, she has a function called foo in her workspace. And we know that it needs HTTP command. So we'll just bring that in. And then let's run foo here now on. So this is RIDE running in a browser, and it has, pretty much the same functionality that it has when it's running standalone. There are a few things it can't do, like it can't have floating windows. Everything has to be within the context of that, but everything works as you would expect. You can trace it. That took a little while because it went out from the Docker container onto the internet, got a megabyte of data. We can hover over variables, see what's in them, and finish running, and there's the output. So she's warming up to this. Tracer looks nice, but I'm really a fan of Visual Studio Code that we've been using at university for the last year. I think that's a very, very nice environment. Could I use that? I'd prefer to use that to edit my APL code, she says. Okay. So since she hasn't installed Dyalog APL, the APL keyboard isn't set up. So we need to set that up. Fortunately, Jeff, how many years ago, Jeff, got the APL keyboards into XKB map Denmark, APL option, switching between groups using the Windows key. It's a very common key to use under Linux. And then she can call visual code, giving a folder name, D18 demo / and instead of noodle, I'm going to open this folder called perfected, which is where the reorganized code is. So we've got a folder called perfected, where we've split the business logic of counting the digits, taking in a character vector as the right argument, from the interfacing stuff of calling HTTP command, get, checking the return codes, outputting an error message, or calling count digits if we manage to get some data. And so if she were to say that this is very good and she'd like an exclamation point there and save it, then if we go back to our APL session and clear the workspace, and this time link hash to app perfected, and enable the Workspace Explorer, we can see that we have this stuff there. I also put the HTTP command in there so we wouldn't need to load it, just to save a little bit of time. So if I now change this and say, this is really nice, save it, then I think Visual Studio Code is actually watching it and pick up the changes in real time as they're being changed. Because although we're running in a container, these folders are shared. So she can use her favorite editor, VS Code, Emacs, Notepad, or Dyalog APL's IDE as she chooses to work with this stuff. And she can run the code. That's the basic function. And if we were to unfortunately, I don't have demo working yet inside when RIDE is running inside a web browser, so I have to type all this stuff. And the thing that always goes wrong is when you type Windows key L to get quad. Since this is a virtual machine running under Windows, Windows comes in and locks the keyboard. So I was very lucky I remembered to click on the quad there on the language bar and saved a few seconds. So app is what was mounted, and in demos, CSV files, .txt, and I'll have them broken up into each line becoming a nested character vector. So there they are, and now that was just to save me typing those names. If I pick the first one, it goes out, gets the file, and returns these 10 numbers of the frequency analysis. Okay, well that's pretty cool. I could certainly use that, she says, but I have a colleague who's writing a little application in Python that might be built on top of this. How can I make it possible for him to call these functions? And to do that, you need to use another container. You need to use the JSON server container from Dyalog. So this is a container that contains Dyalog APL and our JSON server tool for wrapping any namespace as a web service. And the argument to that is, again, the folder that you want to serve, and then the port number that you want it to run on. It's very important to type 8081 there, not 8080. Sorry? Demo, thank you. Yeah. So again, this would download the container if it's not there. Otherwise, it starts this container containing Dyalog APL and JSON server and a bit of script that fires up the JSON server, points it at that folder, and then launches a web browser again, Firefox, in the surrounding system to bring up the HTTP sort of developer tool to work with this. So if I now type count digits and I provide it with some data, this web page wraps that into a JSON payload, sends it, and gives me the payload back. And so this person who's using some other programming language will almost certainly have tools to make JSON requests. I mean, they are so common that you can even from the command line. There's a tool called curl. So if somebody who was just working in Linux scripting wanted to call this from a Linux script, they could write a script like this. The first 2 lines, actually the first 3 lines are just creating variables called URL, header, and data. And then this last line here is what does the business. It calls curl. This switch here says add a new line to the end of whatever returns so that you start on a new line when you've displayed the result. Include the header, which is application JSON. Include the data, which is the name of one of those files, and then call the analyze function. So if we, instead of catting that, run it, it runs that script, and we've called the JSON server from a Unix command shell. Okay, so that's pretty cool. Now, when this project gets underway, I'll have a whole bunch of interns who just need to be running this tool and collecting the results and writing some reports. Would it be possible to wrap this up in some kind of simple web interface? I think this, this HTTP thing is a little bit too primitive for them to use. Could we do a bit better than that? And, let's see, it keeps reordering these containers, or the command shells. This one, yeah. Well, I'm glad you asked that question. D18 demo/website. So open VS Code on the website folder, and in there is a single file. The logs and the sessions DCF are artifacts of having run this web server once. And what's in here is a piece of, this is my server code or DOI code, as I think we're going to start calling it now, that Brian's going to be talking about a bit later. And what it's doing is it's adding a style sheet to give us a chocolate-colored website. It's adding a title. H1 is a header that appears on the page. It's adding an input field, which it pre-populates with the first one of those files to save us a bit of typing. It adds a button with the caption Run Analysis on. It sets up a callback to call the function onGo. And there's a little bit of styling to control the size of the buttons and colors of things. And then it adds a frequency table of empty output to begin with, and it adds a little area in the screen at the end which is going to contain a chart. If there's a callback, it runs the onGo function, where it gets hold of the input field and calls that file. And then there's a little bit of funkiness because I'm going to try and run this on the web. So I look for a command line parameter to tell me where the JSON server that we're going to call is running. So it looks in the environment to see which IP address to use. You wouldn't have that in production. You'd have that hard-coded. It then calls, you can see it says get JSON, post, analyze, and the file name. So it's making from APL a call to the service on this line here. Yeah. So that HTTP get JSON is like the curl call that we saw in on the command line. And then it calls a little chart that does a little sharp plot chart down at the bottom. So let's see what that looks like. Let's get out of here. I hope it doesn't really mean it's going to suspend soon due to inactivity. That seems a little bit unreasonable. So this time we're going to need the my server container, which is just like the JSON server, except it serves up a folder this time as a website. And we're going to run that on port 8080, and we're going to connect. This last parameter is optional and says I'd also like a RIDE connection to this if I want to debug the web server if there's something wrong with it. So there we are. We have the website running, and there's a chart and everything. And it wasn't a huge amount of code. So now she's pretty excited, I hope. And she says, well, that looks pretty simple, but I can't really leave my laptop running all the time so that the interns can use this. That doesn't make any sense. And of course, now this is where the cloud comes in, because all you need to do is to go to some cloud provider, start up a Linux virtual machine, install Git and Docker, as she started by doing, and then you can run this. And we'll go all the way back to Windows now and start PuTTY, which is just a TTY program. And as it happens, I have started one of these Linux virtual machines on Amazon Web Services before we started. I'm just logging into that here. And I've done a little bit more work here because I know I'm going to start those two things always that are going to work together. And if we go into D18 demo/service, we'll find a file there called Docker Compose YML. It's in YAML. And what's in there is just a declaration of two services, one called Engine, which starts from the image Dyalog JSON server and maps the volume perfected into app. Another one, which is a service called Website, which uses the My Server container from Dyalog and maps the website folder into app in the container. And then we expose two ports on the service, the web server 8080 and the RIDE interface in case we need to debug it. You normally wouldn't do that on something just running out there on Amazon, at least not with adding some kind of security, and we'll talk about that on Wednesday. And then I set this environment variable to say the engine is just, it's running as on port 8080 on the machine engine. And internally within this thing, when it starts the two, they can refer to each other by using DNS by the names that have been set up. So each one can easily see and communicate with the other machine. And all I need to do to get that to run, this is really beautiful, is you say docker compose up. Now this is running now on Amazon, so it doesn't launch anything, but if I go here and I say AWS DC 8080, that's out in the World Wide Web, run the analysis. So all of her interns could be using this website. It's public, it's running in Ireland somewhere, in fact, on Amazon. And if something goes wrong with it, and I've decided to keep this open, I would have protected it with some certificates and so on. I can go to port 4502 and tell you what, I'll type off before anybody gets a bright idea of repeating that. All right. So, what's not to like about this? So it says, okay, I need to learn more about this. What do I do? Well, you could go to try APL, and there's a REPL there with tutorials and lessons. Or you could, from the comfort of your Linux virtual machine, you could, let's just start a, is this one still available? Yeah, you could just call the Jupyter container, which starts up something called Jupyter Notebook and serves up all of the Jupyter Notebooks that Will and Adam have been working on recently. So you could go to grading and sorting, and is Jupyter Notebooks, as you may have heard, are this collection of markup and executable APL expressions. So you could, read this, you can look at the examples, and you can modify them and execute them, and it's connected to an APL engine that's running in the background. So there you are. You can run as a web, a web service, a website. You can start the interpreter, all without installing Dyalog APL at all. Back to PowerPoint for a few remarks. So, the technology that we used here, Dyalog APL, GitHub, get used to it. GitHub is something that you need to get used to. We'll all be using it in a few years. It's not that hard to use, and we're going to see Paul and Gil are going to be giving presentations that hopefully will help you move in that direction. There's really not that much to it. Docker and Docker Hub, those are really the new technologies driving the cloud. It is so easy to create these containers and run them on the cloud. And I'll be talking more about how this stuff was all built on Wednesday. Visual Studio Code, I think I've been using it for a few days now. It's very, very nice. I might actually end up editing a lot of APL code there, believe it or not, although I've been using Dyalog APL for decades. And of course I used the AWS EC2. The cloud is a good home for APL. The road signs even, the road signs look more like the kind of thing we're used to when you're in the air. This is more like our kind of notation. And these Docker containers really favor lightweight, compact tools that don't need big frameworks. You just need a little bit of internet connectivity, something that can generate HTML, you're up and running. The APIs are simple, and it's like APL is coming home. It's feeling a bit, to me, like 1979 all over again, when we had very comfortable environment to run APL in. That's what that sign actually means. You're at alpha, you've got Charlie going in both directions, and taxiway alpha goes off to the right. And Docker is all you need. I've said all these things already, so I'll move very quickly here. The interesting thing about this is it seems to be equally attractive to new users coming out of university who want to get things up and running very quickly, and our biggest corporate customers who want to do all this continuous integration, deploying their application on the cloud, building these little containers containing APL to build and test and deploy your system. is surprisingly easy and reliable technology. We have work to do, and Jay, if I give him any time, is going to talk more about what that is. I'll just mention a few things. We need the license, talked about that already. We need more of these public containers. It occurred to me yesterday in a workshop, we immediately need a tamstat container where anybody on Windows, Mac, or Linux can just type tamstat and the name of a folder containing their statistical data, and bang, tamstat's up and running without them installing it. We need better integration with these tools, external editors, and we really need to define what a project means to us. And there's going to be talks about that as well. One of the most important things I've realized we really need to give high priority now is this .NET Core. Because although we need only thin layer of APIs, we will need the .NET Core. And the .NET Core has become an open source, cross-platform set of libraries. And there will always be things that Dyalog isn't going to put into the interpreter, and this looks like the best candidate for a library. We really need to embrace script-based applications. We're talking about. But I'll move on. We need to learn a few things. How to need new types of maps. This is actually current. This is what's happening now. Fortunately, that front system there is going due north, and it's going to give us a miss, I think. But it might rain a bit. I don't have time to do these. They're in the program. There's lots of talks that are somehow related to these new technologies, and it's really nice to see that the work we've been doing for the last 3, 4, 5, well, you could say 20 years, is finally really starting to fit together in some things that I think are really attractive. And next year, yeah, thank you.
Well, we'll see how it goes. Okay, can you hear me? Yes, you can. Right, thank you, Morten, for taking us out into outer space. Now let's come back down to planet Earth. So my job in the next half an hour is to tell you what we've been doing for the last year, what we plan to do for the next year or so, and hopefully get you to the coffee break on time. Fortunately, we've got, as Morten mentioned, a really good program this year, so for a lot of the features that I'm going to mention today, rather than me try to tell you about them in great detail in this short slot, I'll just post you to talks later on in the program where the people more qualified than I will tell you about them instead. So I'm going to talk a bit about version 17.0, which was released this summer. I'm going to talk a bit about the next release or two that we've got coming up, and some other things that we're doing. Version 17 was released pretty much on our usual schedule in the summer, a few weeks later than usual, and had a collection of new features, large and small, which I'll go through quickly. Starting with small but important things. The error diagnostics in version 17, I hope you'll notice when you use it, have been improved so that the little caret you get, which has previously given you some incredibly vague indication of where your error might have been, now for the most part points at the function that caused the problem. And we've also, since Quad DMX was introduced, I don't know, 7, 8, 9 years ago, we've been working to improve that so that when you get an error, rather than say just file name error, you might get the name of the file and what exactly caused the problem. Hopefully that will make your daily programming lives a tiny bit easier. In the name of cross-platform portability, we've been working on portable file functions since I think they came in version 15. In version 17, we've increased the set of functions, so there's new functions for copying and moving files, and also those functions and a bunch of the existing ones have been improved so that you can operate on multiple files at a time. So, for example, you could copy or move either several files that you've named or a whole directory tree full of files. Also, Morten mentioned bracket link, which is to do with writing APL and keeping your source code in script files. Bracket link is a new user command that helps you synchronize APL's view of what source code you have and what files it lives in with the host operating system view. So, for example, if you're working in a local Git repository, the APL session wants to be running and using and perhaps editing the code that lives there, but you might also do a Git pull or use an external editor or something else that is going to modify those files. Bracket link is a tool that will help keep those two things synchronized, so it actually notifies the APL session when files have changed so that your APL can respond to that, and the same thing can happen in the other direction. If you edit files in the APL, hopefully your host tools will notice and keep the whole thing synchronized. And in a similar vein, to do with working with Git or working with at least modern version control systems, one of the problems that I know some customers have encountered is if you have more than one person working on your source code at the same time, the source code control systems tend to work well as long as you don't have two people modifying the same line of code at the same time. And a problem there is if you're working with traditional functions and you have a lot of local variables, you quite often find that any time you change the function, you end up modifying line 0, which could have, dozens of local names specified on it. The locals lines feature is a way of breaking up line 0 so that rather than specifying all of your locals on a very long line, you can split it up and have extra locals declared on line 1 or 2 or 3 of your function. And there's another new user command, bracket help, which is designed to... I've been told to stand in the glare. Bracket help is designed to fill in some of the gaps left by the F1 interactive help system. Bracket help is a user command that pulls together all kinds of help for different kinds of things you might want to know about, user commands and primitives and OO things and everything, and brings them all together. Version 17 also brings some improvements to the HTML renderer component, which is something Morten didn't really touch on in his talk, as well as trying to make it easy to run services in the cloud, which mostly run headless, i.e. with no user interface. We also want to provide tools for doing cross-platform user interfaces that will run on desktop systems. Traditionally, that's usually been on Windows for us. But the HTML renderer GUI component is a cross-platform thing, and we've introduced improvements into that into version 17, mostly under the covers to try and make it more robust when you use it, for example, as a smaller part of a larger Quad WC GUI on Windows. I'll talk a little bit more about our future plans for that in a moment. And there was also a new, slightly experimental feature called APL as a shared library, which is, again, a slightly different model. Imagine you have a larger application that is not all written in APL. It could be in a whole bunch of languages, but you want to do some of your core calculation in APL. The APL as a shared library is about wrapping up the APL part of that in a way that can easily be called from other languages. Very similar to the way that you can create a .NET assembly on Windows to wrap up your APL code to look like a .NET component. This is taking it to a slightly lower level than that and wrapping up your APL code as a shared library that pretty much any other language on the planet can call into. So you can, as I say, wrap up APL calculations such that the rest of your application doesn't need to know or care that it's written in APL. It will just look like a library that can be called like any other. Along with version 17.0, we released RIDE 4.1, which had a bunch of work done under the covers to reintroduce support for floating editor windows, which I think were sorely missed when they disappeared from the previous version. We completely replaced the actual code editing component in RIDE in order to get much better performance if you're editing large scripts. For example, if you have a scripted namespace that runs to several thousand lines, the performance should now be a lot better on that. And we completely revamped the look and feel, and RIDE is now considered to be the default user interface on every platform except Windows, where we still have the classic IDE. And that's what RIDE 4.1 looks like. Now, I said there's a mishmash of new features. There were also some quite important changes to the language. The big new feature that went into version 17, which took a significant amount of design effort, is called total array ordering, which is extending the domain of the grayed up and grayed down primitives to include arbitrary nested arrays. Previously, since grayed up and grayed down were invented decades ago, you could only sort simple, flat numerical character data. We've extended this now so that you can sort nested data. In particular, you can do things like sorting a vector of character vectors, which is incredibly handy. Previously, you couldn't do it without resorting to some tricks like mixing your data. So that affects grayed up and grayed down, and it also works very nicely with the newish interval index primitive. And if you want to know more about that, I suggest you go and watch the webinar where this guy and Adam will try to explain all the nitty-gritty details and show you some use cases. And one more small extension, anyone who's in the workshop that we ran yesterday morning about performance will know we were talking about extending the set functions to work on higher ranked arrays. In version 17.0, we did that for unique. And as usual, we've done a lot of work on performance. In particular, in the last couple of years since Marshall Lockbaum has been working for us, he has been working pretty much full-time on performance. He has a lot of extremely good ideas. We tend to flash up these charts on the screen when we're talking about performance. We've been doing these for a few years. They're supposed to give you a kind of overview of how the performance has changed from one release to the next. And this is the chart we produced for version 17.0. Actually, it's become clear that for a couple of reasons, you know, these charts give us a nice warm, fuzzy feeling when you see a lot of blue on the graph, but they don't actually give you a huge amount of detail. From looking at that, in fact, you have no idea what the things were that are sped up, and you also have no idea how far that blue tower on the left goes up. It goes way off the top of the graph, but how far? For version 17, so in addition to that graph, there's also a web page. You can find this just by Googling for Dyalog performance, I think, where we've got a write-up of exactly what kind of cases we've improved, what kind of improvement factors you can expect. So if you have any interest at all in exactly which kinds of code you can expect to run faster, or perhaps what new fast-performing algorithms you might want to try and take advantage of, I would suggest you at least take a look through this web page. And we'll try to do that for releases in the future as well. Try to describe in words what kind of thing we're working on for performance. So that was version 17. It was released in July. If you want to know more about this, I suggest you come to our workshop on Thursday afternoon, where we will show you some of these features and walk you through some examples and get you to try them out for yourself. On to the future. Gita mentioned already that we're planning more than one release ahead. Usually when I stand up here in September or October, I can tell you about what's coming up in the next release. Today I'm going to tell you about what's coming up in the next 2 releases. Our plans at the moment are to put out a version 17.1 earlier than normal next year. So that's going to be quite a shorter than usual development cycle for us. As well as that, we're planning to put out a version 18.0 at the usual kind of summertime slot the following year, in 2020. And the reason for this is that for version 17.1, we have a relatively modest list of features. It's really to do with completing some things that we hoped to complete in 17.0, which didn't quite make it, and tying up some related loose ends, trying to make especially some of the Docker-related stuff that Morten's been talking about work a lot more smoothly. Whereas version 18.0, because we're already starting to plan and implement stuff for 18.0 now, it gives us a much longer runway before release, and we're trying to plan some really ambitious new projects for 18. And the important thing about this is that these 2 releases are both being developed right now. We're developing them concurrently. So it gives us a long time to plan and implement some of the big projects we want to do for version 18. So 17.1 first, which should be released earlier than usual next year. The kind of defining features for this are to really get the HTML renderer working properly on all platforms. This was a goal for version 17.0 that we were close to achieving, but there are technical reasons why it turned out to be difficult, in particular to get this working nicely on the Linux desktop. Version 17.1 should have all of that sorted out so that the HTML renderer works on all of our desktop platforms, which is Windows, the Mac, Linux, and I'm not sure about Raspberry Pi, actually. Windows, Linux, and the Mac, let's say. And the other thing we'd like to do for version 17.1 in particular is to get better support for running APL in headless mode. That is, running it in a Docker container, running it in the cloud where there is no user interface. Now, Morten's shown demos of this already, so it does work. There's a workshop, I think, on Thursday afternoon concentrating on this, so you can see for yourself that it does work. You may also see that there are a few rough edges and things that don't work quite as... It's not quite out of the box. It doesn't work quite as straightforwardly as it should, partly to do with running the APL headless in the first place, and partly to do with connecting RIDE to it and getting that up and running really easily. So we hope to sort out all of those rough edges and tie up those loose ends. Of course, we can't stop ourselves doing a little bit more than that, so also for version 17.1, I think we need to do some work on the packaging, especially for Linux, which I'll mention in a second, and all of the sort of usual day-to-day minor bug fixing, minor new features and performance work. We're not going to try and hold that off for version 18.0. That stuff will go into version 17.1 as well as usual. Now, I mentioned we wanted to tweak the packaging a bit. We've said today that if you're running in the cloud and using Docker, typically that all happens on Linux. You can run Windows images in the cloud, but if you want to run a full version of Windows in a cloud image, typically the image size is, 6 gigabytes. Microsoft have something called Nano Server, which is a drastically cut down version of Windows, which comes in at under 0.5 gigabyte. Whereas at the other end of the scale, if you run on a completely minimalist Linux distribution that's kind of custom built for running in the cloud, you can get images as small as 2 megabytes. So sitting in the middle there are Dyalog APL installations. Now, the two things I said we wanted to do for version 17.1 are get the HTML renderer working and concentrate on Docker support. Now, there's a bit of tension there because the HTML renderer is based on the Chromium framework, and once you bring that into a Dyalog installation, it bumps up our installation size by well over 100 megabytes. Conversely, if you're running in the cloud, you want to try and keep things as small as possible. So once we have sorted out the licensing issues to make it easy to install or to get hold of APL for Linux, the next thing I think we need to do is to sort out some packaging issues to make it easy to decide which parts of the installation you want. So in particular, it should be easy to get a minimal installation that doesn't include the HTML renderer and other things that you only need on a desktop system. And it should be easy to get the full desktop installation if that's what you want to run on your development system. And following on from that, we are probably going to have to bump our minimum version requirements for Linux. I can tell you more about that if you're interested, but I'm already running short of time. Performance, I will come back to. So, onto the exciting stuff is the version 18 release, which is scheduled for summer 2020. Now, what I'm going to tell you now are our plans and ideas for some of the big projects that we want to tackle in version 18. These are not promises. Many of them have not been fully designed or planned yet. Pretty much the only thing I can promise you is we probably won't get all of them finished to our satisfaction in time for version 18. This is really to whet your appetite and tell you the kind of thing, the big things that we would like to tackle. And they don't come much bigger than everything. First thing I want to mention is the theory of everything. I'm not going to say too much about this because John Daintree will be explaining it in detail tomorrow morning. Just to try and say what it is in a sentence, it's an internal object model for Dyalog APL. It's a way of exposing to the user metadata about what's going on inside your APL system and the system itself and the environment you're running in a kind of structured way. It can do a lot of cool stuff, and I'm sure John will show many of them tomorrow. The next one, this is kind of, in some ways, just a technical detail. Dyalog APL, I think since day one, has restricted the maximum rank of an array to 15. Now, most of you, I would guess, don't generally run into that limitation, but we do have some customers for whom it is a serious problem. They're running into the limit. Life is getting more painful for them year on year, and they're seriously considering switching to R or MATLAB or something for parts of their calculation because they simply can't do it in APL anymore. We would like to lift this limitation. The downside is that this is going to be one of the most invasive changes we've made to the core of the interpreter for a long time. And it also affects the backwards compatibility story. So we take backwards compatibility very seriously. You can load old workspaces. Workspaces are kind of binary images of what goes on in the interpreter. You can save in one version of APL, and you can load it into a different version of APL. Anytime we change the data structures in there, we have some work to do to kind of fix up the differences and bring it up to the modern standard. Increasing the maximum rank of an array involves changing those structures in a very fundamental way. It also will affect the structure of components on component files. Another thing you've always been able to do with Dyalog APL is write simple array data to a component file in one version and read it back in a different version, whether that be a later version or an earlier version. Now, we certainly don't want to break that model we have a lot of work to do to work out how to do this without affecting that experience. It's possible, depending on how we do this, that we may need to patch older versions of the interpreter so that they're able to cope with simple array data that was written by newer versions, but that hasn't been completely decided yet. The end result of this should simply be that you can create arrays of much higher rank, you know, perhaps up to 64 or whatever seems to make sense. And there are a bunch of other limitations that we should address at the same time. For example, sometimes people execute very long strings of numbers in order to import data, and you run into limitations there. Like, I don't think you can have more than 4,000 constants in a string that's executed or in a defined function. Skip that. I shouldn't skip a slide that's got a warning symbol on it. This is, Geeta mentioned that we put a lot of effort into preserving backwards compatibility, and it sucks up a lot of our resources. It actually makes us less productive because we have so much work to do to make sure that we maintain binary compatibility with old versions of the interpreter. One of the things we would like to do, if we can, is to remove the ability to load a workspace when you're in the middle of running your code that was saved by an older version. So at the moment, you can run some code in version 12, I don't know, you can trace into some functions, and you can save the workspace at that point, you know, perhaps with a quad save, and then you can load it into a later version and resume with the SI stack intact. I don't think that's a good thing to use operationally as part of your application deployment. It causes us significant problems to carry on supporting it. And I would like to remove that facility. If you think that might cause you problems, for example, if your application deployment does depend on quad saving a workspace with a stack and then quad loading it later, come and talk to us and we'll talk about it and we can advise you. .NET Core Bridge, Morten spoke about. Currently on Windows we have a .NET bridge. .NET Core, although it shares most of its name with .NET, is actually a complete re-implementation done by Microsoft of a .NET-like thing. It's open source, it's cross-platform. I think it runs on at least Windows, Linux, and Mac. If you are into running Windows images in the cloud, you're probably looking at using Windows Nano Server, which only supports .NET Core. It does not support the classic .NET. The downside is, because it's a complete re-implementation, it's actually a significant amount of work for us to create a bridge to .NET Core that will give you the same kind of functionality that the current .NET bridge on Windows gives you. But I think it's important. It will allow support for headless Windows operation, and it will give us access to APIs on Linux and Mac in a way that we've never really had before on those platforms. Array notation, getting onto more languagey issues. You have probably seen Adam speaking before about his ideas for a literal notation for arrays. The way I like to explain this is it does for high-rank arrays what strand notation does for vectors. So it just gives you a way of constructing higher-ranked arrays in your APL code in a more declarative fashion. You can just write them as opposed to having to use a lot of primitive operations to construct them. And that has big implications for storing your code and your data in text files. Adam will be talking about that straight after the break. Another big idea, magic arrays. I don't think we've spoken about this publicly before, but it's an idea that has been floating around for a few years. Dyalog APL itself doesn't have a way of representing a sparse array. It doesn't have built-in support for inverted arrays or, tables stored as vectors of column vectors. If you want to use those at the moment, you have to change your APL code to, rewrite your APL code to work on those forms explicitly. The magic arrays idea is a way of you or a sufficiently advanced APL programmer writing some APL code that is a description of what you want the internal representation of your array to look like. The magic part is that having created one of these things, one of these arrays in your user-defined format, you can wave a wand or wave an I-beam or something, and from that point on, that thing will appear to the rest of your APL code just as a normal array. So, for example, if you have 1 million lines of business logic that is already working on matrices, you will not need to rewrite that code. It thinks it's working on a matrix. Under the covers, it might be working on inverted tables or something. And the magic, the clever APL that you have to write is, this syntax is by no means finalized. This is just a sketch, but perhaps you'll have to define something that looks a bit like a class and tells the interpreter how to implement any primitive functions that you're interested in on your particular chosen representation. So we think this will be useful for sparse array representations and for inverted tables. I suspect it will be useful for hundreds of other things that we haven't even thought about yet. I think I'm probably out of time now, yes. We're in no rush to implement new primitives and new operators, but there are a few forms of composition that I think we should probably think very seriously about putting into version 18. Under, I think we've spoken about before, over is even simpler and very closely related. I won't explain those now. We have ideas for allowing you to write config files that describe a configuration of the interpreter and an application. So currently, if you want to configure your interpreter, you typically do that by putting things in the Windows registry or in environment variables or on the command line, and those systems are different between Windows and Linux. The idea of having a config file is it will be a cross-platform way of specifying these kind of things that you can easily package up with your application that says how to run the interpreter for your application. You can easily share it between different interpreter versions when you're upgrading, and you can easily share it across platforms. And as Morten mentioned at the end of his presentation, we want much better support for executable scripts. We've been pushing for you to store your source code in text files for a long time. We also want to make it very easy to run your code or your application directly from text files. So those are the things that the big ideas that we're trying to work on for version 18. What else are we doing? We're working on RIDE. To be honest, there isn't a huge amount of new functionality we have planned for RIDE. Morten also showed VS Code integration. The reason I mention those two is that they share a lot of the same technologies, and Gil will be telling us about that this afternoon. So I'll leave that to him. Gil will also be talking about package management tomorrow morning. And we are always working on performance. We have this year, I think, 3 talks concentrating on performance. Marshall is going to talk about some very cool, very fast implementations of set functions. Roger is going to talk about the wonders of inverted tables. And Marshall's going to try to explain how it is that interpreters can sometimes have the performance edge over compiled languages. Co-defense development is continuing. Aaron will tell us about that from the inside this afternoon. And we have Eric Wallace later in the week who will tell us about that from the outside as a user of co-defense. And even good old defense themselves are still getting some love these days. I'm pleased to say that John Skulls has done some serious development work on the implementation of defense, which I think he might mention on Wednesday morning. in summary, I'm out of time. Coming up, version 17.1 due out early next year, 18.0 due out in its usual slot in 2020. Thank you. Overrun for the coffee break now. I think we should start back here at 11. Yeah. I was also asked to tell you, if you do have questions, we're a bit short of time now, but if you do have questions...